All right, Sleeping Warrior round 2. So Anthony made a response to my video where I showed where the mountain should appear relative to Blackpool Tower if we were on a flat Earth, and it was obviously way above where the mountain is in reality. So let's have a quick look at Anthony's video.
Oh my God, Ruhif, you don't know what to do here at all. You don't know your maths, you don't know anything about refraction. And here you are talking as though you're some kind of authority, and you're clearly wrong. You don't know what you're talking about. Please stop talking about light. Please stop talking about geometry. You don't know what you're talking about.
Yeah, Anthony, that was pretty cringeworthy, to be honest. Like I can hear it in your voice. You don't even believe yourself. Look, even the flurfers know you're terrible at maths. And you know what? It's actually nothing to be ashamed of. Plenty of people are shit with numbers. The difference between those people and you is that they know they're shit at maths, but you think you can go around correcting people.
Now I'm going to ask this again. If you have a triangle with sides of 1, 1, and 1, what are the angles?
I'm gonna pull up a triangle calculator.
Like I said, nothing wrong with being shit at maths, but you're just not in a position to tell anyone that they're wrong.
But what we can do is we can put in the eye height of the observer exploring the plane, just under 300 feet, and we can put in the target distance of the mountain, and we can see that the target hidden height is 2125, but we know that the mountain itself is, where is it? 2546. So I mean, look at the difference there. I mean, there's virtually nothing. So we go from 2125 to 2546. It's like 400 feet. So we know that we're only supposed to see 400 feet of the top of the mountain. Do you think that you're looking at 400 feet for the top of the mountain that's 77 miles away?
No, I don't think I'm looking at 400 feet because refraction is a thing and it lets us see more of an object than we otherwise would be able to. So with standard refraction, the hidden amount goes from about 2100 feet down to about 1700 feet hidden, which is another 400 feet on top of that. Now there is some obstruction by the sand dunes at Formby. So for shits and giggles, let's figure out how much we are actually seeing. All right, so here is ETP's original image. And what we're going to do is try to identify these two little boobies on the left. Now we could scroll around all day in Google Earth and guess where they are, or we could use some 7th grade mathematics to work out exactly where they are. All right, so let's do some photo analysis. All right, so here are the coordinates I have for exploring the plane. And on Google Earth, what we're going to do is draw a line between those observer coordinates and Blackpool Tower and record the heading. Or you can use some spherical trig to get the heading even more accurately. And that heading turns out to be 5.841 degrees. The other thing we need to do is get a pixel location on the x-axis. And on my screenshot, which is 1680 pixels wide, the x pixel for Blackpool Tower is 606. So let's put that on the photo. All right, let's do the same for this tower here, which is called the Ice Blast at Pleasure Beach. It's one of those freaking terrifying rides that just drops 40 meters or so. And here are those measurements. And finally, there is a big radio tower next to a gym called Bannatynes Health Club in Blackpool. And here are those measurements. All right, so hopefully some of you recognize this spreadsheet. This is just the data that we got from the image. And all I've done here down the bottom is plot a simple graph of the heading against the pixel. And as you can see, it makes a nice straight line. So if we want to find the heading of literally anything else in the image, we just need to extend that straight line in the graph and then cross-reference the pixel position and see what heading that works out to be. So on my screenshot, the left mound is at pixel 172 and the right mound is at pixel 242. So all we need to do is plug them back into that scale that we just derived and voila. We have some really precise headings that we can follow on Google Earth to see what those peaks are. And here are those two lines drawn out on Google Earth. Now the elevation data is really poor quality in this area. So I've had to go to Ordnance Survey maps. And as you can see, those two little bumps collectively called Little Heart Crag. And Little Heart Crag has an elevation of 2,090 feet. So there you go, Anthony. That's what you can do if you actually know your maths. But here is the problem. So we've got Red Screes up here at 2,546 feet and Little Heart Crag at 2,090 feet. And I think most people can probably see already that this is looking a little bit ominous, because if this is 2,500 feet and that's 2,000 feet, guess where 1,500 feet is? And 1,000 feet. And 500 feet is literally off the screen. So I wonder where sea level is at Red Screes. It's off the fucking bottom of the screen, isn't it? All right, and while I'm here, I may as well have a dig at Brian, who seems to think that there's some freaking magical adjustment that I need to make to take into account angular size. So here is an exercise for you, Brian. Let's take Blackpool Tower. We'll say that the sea level at Blackpool Tower is roughly the same level as Formby Point. So it's about 520 feet tall and it's 32 miles away. And you all know the rules of perspective. Double the distance, double the size, that sort of thing. So it's 77 miles. Something with the same angular size as Blackpool Tower is about 1,250 feet. And that's almost exactly half the size of Red Screes. So I wonder where zero elevation would be if we added a second one. Oh wow, still off the bottom of the fucking screen. Exactly where I said it would be in the last slide. Anyway, I suppose I should tell everyone where this huge mistake is that I made. And Anthony is correct, I did get the predicted height of the mountain wrong. So in the last video, I calculated where the top of the mountain should appear, which was 362 meters above sea level at Blackpool Tower. And I tried to put that height on the image. And Anthony's right, it does look pretty ridiculous way up there. And the reason I put it up there was because I thought that the base of this tower here was 37 meters above sea level, according to Google Earth. So all I did was use those 2 points, the base and the observation platform, and scale it up to 362 meters. But as it turns out, that little tiny corner that we can see jutting out from Blackpool Tower is actually this building in front of Blackpool Tower. And that little brick column is 49 meters above sea level and not 37. So when I redo the calculations with that new scale, it obviously changes where I place the 362 meter mark. It goes from here to here. So yes, Anthony, I agree. Things would look ridiculous if the Earth was flat.